Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is merge k sorted lists. It's a hard level problem and it's also very popular problem, as you can see from the likes. So let's read the problem statement. That we are given with an array of k linked lists. So we are given with k linked lists and each linked list is sorted in ascending order, and we have to merge all the linked list into one sorted linked list and return it. So for example, if you see, we have three linked lists in this list, and all these three are sorted, and we have to merge these three lists in such a manner that the resultant is also a sorted linked list. So let's see how we can do this problem. So we have already talked about merging two sorted lists in one of my video linked list playlist. You can watch that, and after watching that video you will get some idea, like on a smaller number of lists, exactly two sorted lists, how we merge. And there is a detailed explanation with the help of pictures and diagrams for better understanding. After watching that video you can continue this video. Let's see with an example where we have three linked lists. So I've taken PriorityQueue as well as a min heap so that I can know the minimum from the three lists. So first, in this min heap we will add all the first elements from the three linked lists, so like 1, 2 and 3. So as it's a min heap, it will arrange the elements of the three linked lists in the increasing order, right? So we at a time there will be three elements, so means the size of the min heap will be equal to the number of linked lists. For example, for this example we have three linked lists, so size of PriorityQueue is 3. Now we have taken one dummy list node and a tail list node. So currently the minimum element is 1 from the min heap, so we will poll this element and we will mark tail.next as 1. And as soon as we do tail.next is equal to 1, dummy.next will also move to 1, right? And we will remove this link which tail was pointing to dummy. We will do tail equal to tail.next, so it will be 1, right? So now we have 5 as the next element of 1, right? So what we will do, we will keep the remaining elements 2 and 3 of the min heap and we'll add 5, the next element of the first list, because this was the minimum that we polled. Now the minimum heap has 2, 3, 5. Now the current minimum is 3. Now we will poll the minimum element, that is 2. So now the dummy will keep on pointing to 1, and tail.next we will change tail.next from 1 to 2. So now the tail.next will point to 2, and when we do tail.next to 2, the 1.next will also go to 2, right? Because tail was pointing to 1, and when we did tail equal to tail.next, right? So because tail was pointing to 1 and we did tail.next equal to 2, so 1.next will also point to 2. And finally we'll break this link that tail is pointing to 1. Now tail will point to 2, right? So now we have removed the 2 from the min heap. Now the next element of 2 is 6, so we will add 6 in the min heap, right? Now the current minimum element is 3. So now we will poll the element from the PriorityQueue, the minimum, that is 3, and now the tail.next, now tail is pointing to 2, so we'll do tail.next equal to 3. So tail.next will point to 3, right? 1.next was pointing to 2. So when tail was pointing to 2 and when we did tail dot next equal to 3, 2 dot next, right, this link will be broken and 2 dot next will point to 3, right. And finally we have to break this bond, that is tail pointing to 2. We will say tail equal to tail dot next, so tail will point to 3, right. And now the next element of 3 is 4, so we will add 4 in the priority queue. Now the current minimum element is 4, so we'll pull the element 4 from the priority queue. So 1 is pointing to 2, 2 is pointing to 3, right? Now tail is pointing to 3, so we will do tail dot next equal to 4, right, because this is the current minimum. So we will do tail dot next equal to 4, so 3 dot next will also point to 4, right. So if I draw, this is the current link so far, and finally we will do tail equal to tail dot next, that is 4, right. Tail is pointing to 4. Now 4 has no element, right. 4 has no element, so what we will do is we'll pick the next minimum element, that is 5, right. So we will pick the next element 5. So now we have already 6 as element, so for 5, right. So we had till now what we have this link to 2, and 2 is pointing to 3, and 3 dot next is 4, right, and tail is pointing to 4 currently. Now we have to do tail dot next equal to 5, so tail dot next will point to 5, so 4 dot next will also point to 5, right. 4 dot next will point to 5, and we will do tail equal to tail dot next, that is 5. So now 5 has also no element, no next element, so what we will take the last element from the min heap, that is 6, so we will remove 6, we'll pull 6 from the priority queue. So now the current tail is at 5, so and now the minimum element is 6, so we'll do tail dot next equal to 6, so ultimately 5 dot next will also point to 6, and we'll do tail equal to tail dot next, that is tail will point to 6, right. And there is no element in the priority queue, so this is our path from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6, right. This is the order: 1 to 2, 2 to 3, 3 to 4, and 4 to 5, and 5 to 6, right. So we have our increasing order linked list, merged linked list, right. So let's see the code for it. So we have our merge k list function, which takes lists, all the lists of list nodes, and if the list is null or length is equal to 0, we'll return null. Otherwise we'll store the list's length into the n variable, and we'll create our dummy and tail list nodes, and we will create a priority queue of size n, right. N is the length of the lists, and we will and this priority queue will store the elements in the increasing order. Now for each list we'll take one element and add in the priority queue, and while priority queue is not empty, what we will do, we'll keep on changing the tail to the minimum element. We'll pick the minimum element from the priority queue one by one, and will, using the tail pointer tail.next, will attach the minimum elements from the priority queue, right? And finally, when the while loop is done and the priority queue is empty, then we return dummy.next, because dummy.next will always point to the head of the merged linked list. So this is the program for it. Let's talk about the time complexity. So here, if you see, we are adding 3 times first, and then we are adding in the priority queue all the other elements of the linked lists. So in a nutshell, we for addition in the priority queue, it takes log n time, right? It takes order of log n, right? So here the n is equal to k, means the priority queue is of size k, so it will be order of log k specifically. And because we are performing for k lists, so suppose there are k lists, and we can assume that the average size of each list is n, so there will be nk nodes or nk list nodes, right? There will be n times k list nodes that will be added into the priority queue. So the total time complexity will be big O of nk log k. Let's try to run this solution. Yeah, so test cases are accepted, so it means it's working fine. So I hope you like this video, and if you like this video, please share and subscribe. Thanks for watching.